AI's neural scaling laws. Are we simply scaling unreality as far as the mind is concerned? Well, let's take a look. So Walsh Labs channel had a very nice discussion of the current state of AI and its neural scaling laws. To me, but certainly not to the AI folks, this is a tremendous mathematical cathedral built on, well, let's use AI's predict the next token architecture. The cathedral is built on swampland, sand, zero ecological psychology, absence of the concrete world. Our AI folk are so totally, completely, monolithically invested in the computational neural net architecture as a reality of the brain. They're so convinced of this, these possibilities do not enter. So let's see. AI's neural net models cannot cross this line, the line of error, a measure of error, and here in terms of computing power. Massive computing power. A petaflop is 1 quadrillion 10 to the 15th floating point operations per second. A computer of 1 petaflop power working a 24-hour day, 10 to the 15 flops per second times 36 seconds per hour times 24 hours a day. That's what we're talking about in the bottom line of the graph there, the x-axis. It's a measure of throughput, tremendous throughput. But we just can't quite get that error to go to zero. And the same problem holds for model size and data set. Example, model set. 50,000 words in GPT-3. That's the number of parameters. It describes model size. Data set size. We could have all the internet docs of the Earth. Or why stop there? All the docs of the galaxy. Huge data set size. For AI, the question is, can we drive that error to zero? Where does the problem, as AI sees it, start? Where? With the large language model, predict the next word. That is the autoregressive framework we just kind of saw. Einstein's first name is blank. Where does GPT start? GPT-3 with its 50,000 word vocabulary. Task 1 is to compute the probability of each word being associated with every other word. Given the input, namely Einstein's first name is the input, a 50,000 element vector is returned, mostly zeros, with a high value on Albert, 0.81, as we see there. The index value of Albert in that 50,000 vector is 42,950, Wells says. Interesting. As we train the net, we want to bring that error down, also known as the loss value. So given Albert should be 1.0, it's a precise value. We define the loss value as 1 minus that probability, 0.81, and the index value at 0.19, I being the index value, 42,590. This is termed L1 loss. This is a pretty simple computation. A more difficult to derive method, but more efficient, is called cross entropy, which turns out to be the negative natural log of the probability output of the model, or minus ln p sub I. The more confident the model, the more the cross entropy drops. But this no precise answer is the far more normal case. That is, rather than Einstein's first name, the precise answer. This case, a neural net is a machine, a method, a computing model, a mass of neurons, a type of learning, a mathematical model, etc. All are possible, all valid. The fundamental uncertainty, this fundamental uncertainty is called the entropy of natural language in the AI framework. So the data, language, images per AI have a natural entropy. And they looked at this across images and text to image, image to text, and they discovered this nice value, as in the purple box there. So a value at which the error curves flatten out, don't go any lower, except for language. They couldn't find that one. So Google DeepMind 2022 broke the scaling law down in these components, as Welsh Lab shows, a model term, a data term, and irreducible error. Note the irreducible error. In other words, even an infinite model cannot have a cross-entropy loss of less than 1.69. Now it gets interesting. To AI, it's still just a data problem in their framework of thinking, this abstract space thinking. The data exists on a manifold in a high-dimensional space. A little dots there, the data on a manifold. Neural scaling laws reflect trying to learn the shape, the contours, the bumps of the manifold, but with a subset of the points. So the dots, the little bumps might be the number 9 or 8 or a coffee cup. We're just not sampling the points of the high-dimensional space with sufficient density in AI's thinking. So we begin looking at the relation of data points to space, that is a manifold of high dimensions. For example, in the two-dimensional case, we have a manifold of length L. We have 9 data points, our little yellow dots. Each data point on that manifold can be considered surrounded by a little space, in this case, our little squares. So we have D, the data points. We have 9, L, the dimensionality, the length of the dimension is, our manifold is 6. And each little space will be a 2 by 2 space. So L squared will equal D times S squared. So 36 equals 9 times 4, 2 squared, 9 times 4. And S will equal L times D to the minus 1/2, or in other words, reciprocal of D squared, or 6 times minus 1/3 equal 2. If we went into the cubical case, 3 dimensions, then S would be L times D to the minus 1/3. And in general, it's going to grow with the dimensionality. S will be equal to or proportional to L times D to the minus 1 over the dimensionality. So the average distance, S, between points scales as the amount of data, D, we have to the power of the reciprocal of the dimension of the manifold. If sampling density sufficiently molds to the manifold, the test data points will match the training or sampled data points exactly. And when not, we can compute the squared error. So if we had perfect sampling, sufficient density, all the lines would be on the test line there. But here we have a case where our training data point, the yellow point, does not match the test data point, the value. Since we're looking at error, regression, so to speak, we're looking at the squared error. So we're taking D to the minus 1 over D to all squared, or D equal minus 2 over D. The cross-entropy case becomes D to the minus 4 over D. And the question becomes, does this fourth power relation, D to the minus 4 over the dimensionality, hold? To answer this, note, we'd need to know that little d, the dimensionality, the intrinsic dimensionality of the manifold. So AI had cases where this little d was deemed known in small image data and small synthetic data, and this fourth power relation held. An estimate of d derived from this data estimated the intrinsic dimensionality of language at, curiously, 42.1, quite near the meaning of life. But they tested this by estimating the intrinsic dimension learned by a language model and found it to be much higher, around 100. For Welsh, we're left with a compelling theory with real predictive power, but no theory of AI just yet. In other words, approaching this purely on the mathematical manifold, abstract space, dimensionality framework doesn't appear quite to be working. What's the real problem? The real problem, this event, coffee stirring, a four-dimensional, spread over time, multimodal event with its invariant structure, velocity flow fields, radial flow fields there, adiabatic ratios, energies of oscillation to frequency of oscillation with the hand, inertial tensor carried over a haptic flow field as the hand moves, acoustical invariance, clinkings, texture gradients, ratios, flows, is not this. A pile of vectors with spoon, coffee, stir, hand, cream, clink, table. Therefore, not a vector space, nor a high-dimensional vector space, a manifold. Not even 10 to the square, 10 to 100, not even 10 to the minus 6 to the 66. This event, with its concrete dynamics, cannot possibly be composed or recomposed from those vectors by associating, via these probability vectors, these symbolic elements, which we picked out of the coffee stirring. These elements are differentiated as aspects of a multitude of possible aspects. We'll add some more. This could go on for a long time from the event. They're differentiated or dissociated from the whole. And there's a myriad of aspects that have no symbolic designation in that particular event. These are just the ones we decide to designate symbolically. AI, we might note, assumes this dissociation, this parceling out, shall we say, of invariance involved in the event. It has no idea that this is something that itself that has to be accounted for. That one can impart understanding of this concrete dynamical experience via these associated elements, or that this is understanding, is, well, kind of being a little too left-brained. Now, I likely spoke too soon. The AI folk will say, well, all we have to do is connect or tie the word vectors, and we'll take our vectors into even a nice sentence, that man stirred the coffee with a spoon, tie it to the image or images, and then to a robot arm, and we'll have understanding. And what will happen? Well, the event will be parsed into a series of states, or reduced. Each then will become a pixel grid. And weight vectors, instead of for a 9, will be assigned to recognize in the event a hand, a cup, a spoon, etc. in that event. We're simply back to where we started. More vectors, an abstract high-dimensional manifold where the event has been lost. Also lost the 4D invariance structure. The inertial tensors defined existing only over these very concrete flows involving dynamic force, or the adiabatic invariance, also very concrete over fields of force, shall we say. Concomitantly correlated, also intricately involved time, the truly continuous flowing of the event, the instance of the event, so-called, permeating each other, not discrete, building, thus the hand fatiguing, the clinking, sloshing, inducing a, shall we say, a mellow feeling as we're happily stirring the coffee. It is qualia defined over an indivisible flowing time. We're not dealing with a mathematical density of points or states, but true continuity, where each of those points is permeating, interpenetrating the next, and building with time. So, bumps in this abstract, high-dimensional abstract space or manifold is not going to equal, or never are going to equal, coffee stirring. Postscript on ARC and Chollet. We discuss ARC, Chollet and AI's zero theory, no theory, of the image of the external world, the origin thereof, hence of the flexible, reversible, mathematical group use of images and imagination. How about the next day, 03 of OpenAI did, per ARC, 76% of the ARC tasks, leading AI folks to exult that AGI is conquered. Now, I noted in the pinned comment on that video that there were some interesting problems, that is, interesting failures on the test 03 failed on. For example, and I thought they were very indicative of something going wrong, because when you look, they're very simple. Here's an example. In the yellow box there, input, left side, output, right side. We see the little blue squares. The eye catches immediately on the right side that they're extending a line. The horizontal line extends through a group of red boxes and becomes blue, and a second group of red boxes and becomes blue. And then the vertical line extends through a set of red blocks and it becomes blue. If we look at the next example, input, output, see the little blue squares, the blue, and we see that the blue line is extending and the block of red squares turns blue. That seems to be a pretty obvious rule. You can see the next example 3 on the next line, that's what's going to happen. All the red blocks are going to become blue where the lines pass through. Pretty easy, yet AI failed. Here's another one. We see what we're seeing is a whole line of a cascade of gray squares, gray blocks. But the eye picks up that the next set of gray blocks is colored, alternating colors, and we see the little key there, blue, red, green, light blue. And behold, all the blocks are going blue, red, green, light blue, blue, red, green, light blue. So that's pretty obvious. Let's try this one over here. Again, a cascading set of gray blocks, but we see to the right that they're being colored. There's the key, blue, green, yellow. Pretty obvious rule. One can see in the next examples what's going to happen. In other words, these are extremely simple to humans. AI is failing them. It's an index of something very different is happening in AI versus humans. So AGI is conquered. Well, hardly so for Chollet. In this particular interview on Machine Learning Street Talk, very recent, a couple of days ago, Chollet notes that in 2020 already, he noted that across all the AI programs submitted, 49% of the 200 tests, roughly 100, were solved, but each AI itself could only do about 5%. The winner could do 20%. And at the time then, all these little AI programs were simply brute forcing things. There was no AGI involved. They were just trying to brute force massive search through these tests. Hence, he already thought the ARC tests were deeply flawed. They're amenable to brute force, not what he considered flexible thought, creative thought, AGI. So he was already starting the process of getting new ones. He notes in this interview that in 2025, the ensemble of programs hit a total of 81%. So they left about roughly 40 of the 200 private tests unconquered. So for Chollet, he's very afraid. I've seen a couple discussions that AI is just doing brute force enumeration, and these tests have to be extracted, removed from that possibility. He does seem impressed by 03, using more than just brute force enumeration. He wasn't apparently allowed to talk about that yet during that interview. Anyhow, he notes a harder ARC2. He thinks even 03 will only do 30%, and a much, much harder version 3 of ARC is coming. Again, as I noted, he warns that AI is seen to be only doing memorization, not general intelligence. He does not want that. It's an interesting note there in this discussion with Darkesh Patel there, July 2024, that notice the scaling laws we talked about He says are explained by memorization. They're not actually dealing with intelligence. It's interesting because, note, I'm saying the scaling laws are already failing simply because they're not dealing with the reality, with real events, concrete events, invariance laws that define events, etc. However, it's of one piece. What's allowing us to deal with invariance laws, perception, and origin of imagery in the first place is also what's allowing us to deal with ARC the way we do. It's all of one piece. I don't think Chollet, of course, realizes that. He's looking for something like, well, here's his answer. When he's asked what humans are doing, he says, I don't know, but he feels drawn to deep learning guided program synthesis. That is, where deep learning is learning little programs and is putting together programs on the fly that might be able to deal with ARC problems, certain ARC problems in a generalized form. So that's his take on things. It's a very interesting frontier of the battleground, I'll say, and it's, to me, a continuing project of watching. Second postscript. The idea that AI, in addition to its associative neural nets, needs system 2 capability, becoming a thing. Note here in the timestamps on the Machine Street Talk interview with Chollet, reflecting on the narrative shift towards system 2. System 2 is logical, effortful reasoning as opposed to associative derived reasoning. And this is AI bouncing off Kahneman, thinking fast and slow. It's sort of a dichotomy. Associative reasoning, fast reasoning, but one wonders if they want a dichotomy, why not McGilchrist and left brain, right brain, and the two very different phenomena involved with that. Interesting. It'd be an interesting mapping actually between Kahneman and McGilchrist. But there's interesting stuff in this book. There's a decent respect for embodiment, for example. But for AI, it's somewhat illusory. It thinks it's compatible with Kahneman, but this is not what it needs. It's interesting. I noted, for example, one Kahneman example of intuitive, easy, but misleading thought versus effortful thought. This problem, a bat and a ball cost $1.10. The bat cost $1 more than the ball. How much does the ball cost? Think about it for a second. He says a number comes to mind. The number, of course, is 10. 10 cents. Seems reasonable. It's intuitive, appealing, and wrong. He knows that more than 50% at Harvard, MIT, and Princeton get this wrong. 80% at less selective universities. Yet this equally seems an instance of effortful, flexible, reversible, operational, in Piaget's terms, imagistic-based thought. Example, I've got my bat. My number line there goes out to 100 cents. My ball, 10 cents. But I can see now that, the difference is only 90 cents. It's really not $1 more than the ball. In fact, we've got to do some compensation here. I've got to lengthen the top line, and I've got to shorten the lower line to 5 cents, $1.05 on the top line, 5 cents on the bottom line, and I'll get my dollar difference. I can kind of move my little section over there to get the total 110. So I need $1.05 for the ball, 5 cents for the $1.05 for the bat, 5 cents for the ball, and I've got my answer correctly. This kind of thought doesn't have to be this particular mode of imaging, but something like this is going on under mathematics. Mathematics is very abstract, but underlying is very concrete thought over which abstraction is derived. It's not as abstract as AI likes to think. So the difficulty with Kahneman is this. He has no model of perception, the origin of the image of the external world, otherwise known as the hard problem, our experience, our sentience. There's no model there. Hence, no grounded theory of memory, how this experience is stored, because we can't account for it in the first place. Hence, no model of cognition. There's no treatment of the significance of Piaget, the developing group character, mathematical group character of the human use of imagery, which I'd say is underlying the problem he's pointing to as far as system 2. Nothing Ray Gibson, equal-psych, and invariance laws, as we've seen. No view of a biochemical dynamics underlying the brain's specification of a scale of time for this experience, which I think is a nail in the abstraction of AI, that we just have abstract computations. We need, in reality, a very concrete biochemical-based dynamics and mechanics to account for perception. You can't ignore this. You can't start without it. In a word, AI needs to understand why the brain is an entirely different form of device. AI is not getting this from Kahneman. It needs the Bergson-Gibson framework. AI's confidence in its path derives, in my opinion, from ignoring or cherry-picking large amounts of psychological and philosophical literature. I saw Gary Marcus noting this same kind of thing. Or one could say a lack of intuition in being guided to look at the right things. Just my opinion. So lots of thoughts along these lines in this book. In fact, I did suggest to Chollet that he read it, and he said he would, but I don't think he will. Nevertheless, it's what AI needs, a different view of the brain that maybe shakes them out of their stuckness in their framework. So next time we'll see. Till then, signing off.